Ann Arbor's Talk Station, 1290 WLBY. Damian on Design with Damian Farrell. Today, Damian, as an architect, you've got to love what these guys are designing.
I know. It's the most gorgeous, elegant, beautiful thing. I know there's a lot of engineering and thought behind it and science and all that good stuff, but it is just gorgeous. It's beautiful.
It surprised me today. Yeah. This is ArborWind, an Ann Arbor-based company that creates vertical axis wind turbines. As we welcome in Dilip Nigam, he is CEO and CTO at ArborWind, a company that you actually started.
Exactly, about 4 years ago.
And you were a consultant, engineer as well.
Right, for about 30 years we were doing engineering consulting also.
All right, and also with us is Terry Phillips, who's CMO, CSO at ArborWind, and you're also an artist, besides being an engineer.
I'm an artist, engineer, businessman, you name it. Cook, chef, you know, whatever I need to be. But
designer. Designer. We've missed designer there.
Extraordinary.
Dilip, you have to describe for our radio listeners what this looks like. It's not your traditional wind turbine.
Exactly. Instead of the propeller type, the horizontal axis wind turbine, this is what's called a vertical axis wind turbine. In the sense the blades are rotating about a vertical axis. So some people have said it looks almost like an egg beater. So that's probably the best way of describing it.
That's a good way of describing it. An upside-down egg beater.
Exactly.
So 3 blades, pinned top and bottom, very elegant, very slender, that are in what some of us might think of as a catenary curve, but you have
troposkene.
Okay, you have a fancy name for it, right?
Yeah, the correct mathematical term is troposkene. It defines a curve. Catenary or sine curve is a different type, but this is what's called a troposkene. It's the shape a spinning rope would take, and that basically helps minimize bending stresses, so we can make sure this will last 50 years.
Wow. And the wind turbine industry, how old is that?
So the original idea came from a French engineer by the name of Darius back in 1930.
Okay.
But they could not figure out how to make this thing last, because a turbine that breaks down every so often is not a very functional design.
No, it's not.
So our trick was, and our challenge, how to make this thing last 50 years with minimal maintenance and low upfront cost, yet very productive. And that's what we were able to successfully pull that off. It took us 10 years to get there. We're kind of slow, but it took us 10 years to get there. But that's really was the challenge.
And Terry, what role did you have in all of this?
What I did, there's always some I's are dotting, T's across. So this is a very simple but complicated and comprehensive system too. So there's electrical components to it. There's mechanical components. Dilip is definitely the expert on the mechanical side of things. And there's also the marketing and design side of things. So you got to kiss babies and get this thing known and get it out there. So I came in on the electrical side of it, controls, because the controls are very comprehensive. You can control this turbine from any laptop or any device. So you can stop it and start it. You can see the amount of power that you generate. You can even troubleshoot it. We have a screen where you can troubleshoot this thing, so you can see if it's low on grease, anything. So it's really, really comprehensive. And again, technology affords us the luxury of delivering this at an affordable cost to people.
And Damian Farrell, as an architect, you got to look at this design and just say,
it's
wow.
Just stunning.
You've always maintained things can be functional and have do a service, but why can't they also be beautiful?
Yeah, and you know, in Minimalist, you know, so if you look at, well, Dilip, tell us about the number of parts, because I think that tells the story. In the kind of propeller style wind turbines we're accustomed to seeing as we drive around Michigan, how many parts in something like that?
So those horizontal turbines have about 8,000 parts, and our turbine has only got 19 parts.
What?
So not 19,000, but 19 parts.
8,000 to 19.
8,000 in the traditional wind turbine, and you have 19?
And that's why we can safely say this will last 50 years, because we made a very robust design, yet very cost effective. But yeah, the 8,000 parts, and that's why you'll see a lot of these turbines are sitting like dead ducks in the wind. They're not spinning, because something's gone wrong with them, because there's so many parts. I mean, things do go wrong.
When you do the diagnostics and so on. So that, to me, yes, that's what grabbed me from a design point of view. I mean, someone who pursues design, the more you can pare away and maintain function, that's kind of the grail of great design in a sense. I mean, that's what has generated, if you look at the most beautiful sports cars, for instance, it's the paring away to the minimal shape that works with airflow and so on. That's where the beauty comes in. So this thing sits on this beautiful, elegant, tapered needle, which houses all of its functions. Then it gets up to this elegant, and actually egg beater really doesn't do it. It's just a good visual description, but it is a beautiful thing. I think to watch this thing spin must be just lovely, because it must create this almost pear-like shape once the blades are spinning, right?
Exactly.
Of appearance in the air.
So
very serene.
how does it work?
So it's very simple. It's almost like the best analogy would be like your airplane as it goes down the runway. You generate enough speed, then the plane can lift off. So until that point, it doesn't lift off. So same thing with this turbine. As it's spinning, it's creating the same lift, and that lift allows it to create the force, which generates enough power to run the generator. So it's a very simple concept. But the trick is, how do you make this thing last 50 years? And how do you handle that? Because every time it's spinning around, it's getting pushed one way, then as it goes around, it gets pushed the other way.
Right.
So that fatigue is what your car sees in 10 years. This thing sees in 1 year. So if you don't know what you're doing, this thing will fall apart very quickly. So what we've perfected, and that's part of our secret sauce, which we didn't put in our patent, because we don't want anybody copying it, is how to make this thing last. And that's what took us 10 years. Like I said, we're slow.
Can you give us an idea, though? Does it last that way because of design, or does it last that way because of the materials?
Both. It's both put together.
I'm not going to learn the secret sauce.
So there's a number of factors that come into it, and that's where our 30 years of consulting came in. We looked at literally hundreds of designs. We always improved somebody else's design, and they were amazed. How could we fix a problem that they had without changing much? So like Damian pointed out, there's a lot of inherent, if you understand what you're doing, it doesn't take much to fix it. And that's where our skill came in. We were able to use the latest technologies, like Terry was pointing out, that have come along with computer controls, electronics, fuse that with the mechanical things that we have learned also, and then we came with a solution which addresses all those issues.
We're talking with Dilip Nigam. He is CEO at ArborWind. Terry Phillips, CMO. Terry, you're also going to up the ante here with design in this whole process.
Yeah, I totally concur with Damian's assessment. I think this device, we should know, can fit into urban environments. A lot of turbines, because of their size and setback requirements, they can't go into an urban environment. This can. So if it's going to an urban environment, make it look good. Nobody wants to put it in their city, and it's an eyesore. So that's the benefit of it. We should also note that our turbine is 60 kilowatts. It's classified as small wind and also distributed wind. Distributed means that you can actually use the power as you generate it. Large turbines can't do that. They have to actually go into the grid. So you can actually put this next to your building, and as a turbine is spinning, you have to use that power.
So you don't have to sell it to DTE or however that works
no
by
way.
sending it to the grid, and then you get credits or however.
Which probably
that does
generates
happen.
a whole interesting conversation.
Exactly. Right, it does. That does happen. You actually do get credit, but it's meager. You get like 2 cents back a credit when you actually spin it. So it's better for you to use that power because you're actually paying 10 cents if you amortize the cost of the turbine, which is less than most utility pricing.
So what will 60 kilowatts get you?
So at this point, like Terry pointed out, DTE is charging about 16 cents if you use their electricity, and 2 cents if you give it back to them.
Right.
So it's better to use your own.
Okay.
So this turbine in Michigan would be about $500,000 to install and put it together. But again, the payback is pretty fast, depending upon the different locations. So some places the payback for this machine is like in about 2 years. In Michigan, it would be a payback of about 8 years.
And we should note, too, that there are incentives from the government to help you finance this. There's investment tax credits, like 30%.
And those still exist, right? And
Yes.
those will continue to exist for the foreseeable future, right? Some of these have sunset clauses, don't they?
At least 2016 for the investment tax credit.
Okay.
So that's still
December
good.
31st, 2016.
Okay.
Where can these conceivably go? Beautiful design or not, okay.
So,
But what about zoning laws and things like that?
And that's the thing that we're working with right now. We figured, like farmers, it's easier for them to put on a 1,000-acre farm or 20-acre farm because the zoning is not a big issue. But we're working with cities to improve their zoning because they're used to the horizontal turbines which throw ice and potentially blades. This one doesn't do any of that. So they right now have, some of the cities have a 150% setback requirement, which basically means you can't put any turbines within the city. And they basically are cookie cuttering it, and we were looking at how to help them address that. And said, look, what really is your issue? Because this turbine will survive 135-mile-an-hour wind.
Right.
So I mean, the buildings are going to fall down before the turbine
Before
will.
the turbine does.
So what are they setting back for what purpose? So we're working with them to amend and improve it, because the issues that they were concerned about, like noise, this doesn't produce noise. So they were concerned about being too noisy for the neighbors. This one, if you're 20 feet away, you can hear about 2 decibels above ambient. which means like 100 feet you won't hear anything.
Right. The issues across the country are interesting concerning solar energy and wind turbines, but in particular with the wind turbines out on the East Coast, you've got in the more exclusive areas, people not wanting to look at them out in the bay. Over in California, they've been crying about the birds. You've got this aesthetics down. What about more environmental, birds, that sort of thing?
Right, so both things, I mean, this turbine is efficient even at 20-foot height. So we're selling with a 100-foot tower right now. But if somebody's concerned and they want it really low, like some of the beaches in San Juan, Puerto Rico, and Caribbean, they may not want it as high. And this turbine will produce a ton of energy even at 20 feet. That's the advantage we have.
20 feet, that's it?
Yep. The propeller
If you have
types.
good wind,
Yeah, the propeller types need to be way up there, and they need a lot of land.
How did you do that?
That's it. We started, thanks to the U.S. government, they spent $100 million in the 70s and 80s developing this design, but they couldn't commercialize it. So we took everything they learned and the problems they ran into, and we figured out how to overcome the problems they had, which is basically the durability and vibration problems. And that's our strength. We used to consult with GM and Toyota and others for that. So this is sort of where we brought that to the design. The other thing with birds and bats, birds basically are, when they're flying, they're looking down. They never look up. So the propeller-type turbines basically have, as they're moving, they can hit the bird like a tomahawk chop. And that is what affects eagles and other birds. This turbine we've been running for 3 years. The birds can see this turbine fly around it. And that's the beauty of our design. It doesn't surprise them, so to speak, with the blade
This is
coming down.
amazing.
Because visually it's a form when it's spinning. Right?
Exactly.
It takes on a shape.
Right, and they can see that from far away.
Okay.
So far, we knock on wood, no birds or bats have been killed by this turbine. 3 years already.
Okay.
To answer another question you said previously is about where this will go. Our target is we're looking at farms. Predominantly, like 50% of our target is going to be in farms. This is good for plazas, condo communities. The laws say now that if you can't cross property lines, so if you're on a property line, in other words, if you have a plaza, you can sell the power to all your tenants. But again, if you cross property lines, you become a utility. So it's good. And at 60 kilowatts, that's equivalent to probably like 30 homes. An average home would use about 2 kilowatts. So it's...
That's what I was going to ask, was give us a scale. So about 30 homes
That's right.
for one of these.
Yes.
Could you put one in a neighborhood where neighbors as a collective could do this? Is that considered crossing property
You're
lines?
probably crossing property lines in the neighborhood, but like I said, condo community, you probably wouldn't be, or co-op, you would not be because you have a common property there. But again, crossing property lines, again, utilities don't want us to compete with them, so those laws are in place.
Another issue here in Michigan is, do we have wind?
There's plenty of wind all over the U.S. Now the question is how high do you have to go to get it? So that's the challenge most of the places. So like along the coast of Michigan, there's really good wind. Ann Arbor doesn't have good wind, relatively speaking, but yeah, if you go high enough, there will be enough wind. And that's the advantage of our turbine, that even if the wind is not the greatest, it will still produce quite a bit. It's just that, of course, the more wind you give it, it really shines at that point.
One attribute we need to point out, too, about the kind of wind that we see here. Your horizontal axis wind turbines need something called laminar wind. They need a strong, steady flow of wind coming to it. We can take turbulent wind. In other words, we can hit a roof and spin, and our turbine will still spin.
Really?
We don't need that. What that does for us, we can place our turbines close together, so you can have a cascade of our turbines where you couldn't with...
Guys, I've never seen a design like this. Anyone else working on something like this that you're aware of?
You've seen probably Metro Airport. That's also
Yes,
vertical
it's
axis
vertical.
turbine.
Oh,
yes.
yeah.
But they don't work, unfortunately.
Why
No,
don't
it
they
doesn't.
work?
Again, the design problem, they fall apart within a few months.
Oh, they do.
And they're not economical. I mean, even if they worked, there would be like almost 40 cents a kilowatt hour. So if you can get it from the utility for 15, 16 cents, why pay 40 cents?
Have you talked to them about replacing with your product, ArborWind?
They wanted to buy our design a number of years ago. We said it's not for sale. But since
Development wasn't done yet.
Uh-huh.
Yeah.
so that was a few years ago. Since then, they've gone out of business because we have to have a quality product that will last the test of time. And that's sort of where we took our time to bring it to market once we were sure that it passed all our testing. And after we did all the testing, extensive testing for 3 years, now we're bringing it to market. But yeah, a lot of companies, unfortunately, rush to market. So you'll see some vertical axis wind turbines, but they're much smaller, like 1 kilowatt or smaller,
Yeah.
because they can't handle the big structural. I mean, you can imagine when this is like 50 feet by 50 feet, this is just a scale model, but really it's 50 feet tall by 50 feet
Right.
across. If you don't know what you're doing, it will fall apart very quickly and be a
Right.
danger to society.
And a business answer to that, too, is this, that when you are an entrepreneurial company starting up, there's pressure from investors and so forth to reduce cost.
Yeah.
To reduce cost before you actually have a product on the market,
Yeah.
and that happens with a lot of companies. Also, you have a small window. When things get popular, like apps, everybody runs in and they do a money grab. So the issue with this is to do it right so you can have a sustained business. That's the issue with this.
So you are at what point in your business right now with ArborWind?
We are launching the product. We are in sales, full sales mode with the product. We have a prototype actually up and running, and like I said, we're in sales
And
mode.
where's your prototype?
It's in Marshall, Michigan.
What is it doing there?
Generating power.
For any...
It's an industrial facility. It's a factory. Actually, where we built it is powering that factory.
Oh, really?
Really?
So it's
Why Marshall and not Ann Arbor?
That's where the customer was.
Have you talked to City of Ann Arbor?
we did, and unfortunately, like Pioneer High School is going to put up a wind turbine. They got $1 million grant to put it on the high school. And I wish they'd talked to us. We've been only in Ann Arbor 42 years.
Yeah.
They never called us. So they got a Canadian company to come bid on that. But unfortunately, what happened is they were concerned about ice throws, so they canceled the contract.
But that was a vertical access one.
No, that was horizontal.
That was a horizontal access.
Right.
Yours wouldn't have that trouble.
Issue, yeah. So we wouldn't have that issue of ice throws. But unfortunately, by then they already made the decision not to go forward. We'd have loved to put it at Pioneer High
Couldn't
School.
that come back in to the council table with a new design? It doesn't mean they wouldn't do it in the future, does it?
Well, that's what we were hoping for, because
Right.
I went to Pioneer High School, class of 77, so I'd love to put it in my own high school, and that would have been a great place to start driving 70 miles from Marshall.
Class of 79 at Huron High School. Get it over to the River Rats. River Rats will put it up.
Good give a contact name.
Well, this makes sense
Doesn't it
because
just?
the problems that came up during that Pioneer High School decision and whether to put that up there, you've addressed a lot of them with this.
Exactly. And that's what I say, the biggest thing is how to maintain it. We're in Ann Arbor. We're not going anywhere.
Yeah.
We'll make sure this will be a showcase for us. We would have done it. But unfortunately, I guess we didn't have the right marketing help and all that at that point. So we didn't get to the right people at the right time. We found out about it after it was
Yeah.
too late.
I just find this fascinating.
Isn't it fascinating?
It really is. I mean, I can't believe you've taken this beautiful design that other people have tried, or some have tried, and they couldn't make it work. And with the secret sauce, you guys do it
Exactly.
because of the components and how you put this together and the materials, and it's just amazing.
It looks so sculptural to me. It's,
One thing we have to do, like Dilip mentioned about the airport debacle, is we have to overcome some of that history when we go into a customer.
Well, that's a good point.
And
Yeah.
so we have to educate them, and we do. Again, I'm brought in to do the marketing push, to kind of educate them, take it from here to there,
Right.
to kind of address their concerns in advance. And here's what we do that they don't do. Again, Dilip, 30 years in engineering, 8 years on this product, is pretty well engineered
Yeah.
by now.
there was a recent occurrence, I think down in Saline area, right, of a recently installed horizontal axis.
Right.
And that thing destroyed itself, right, after 30, 40 days or something?
Yeah, in 2012, there was a 55-mile-an-hour wind that went through Ann Arbor, Saline area.
Right.
So these poor guys that put up their turbine barely lasted 47 days. And that turbine literally self-destructed in a few minutes. And our turbine in Marshall saw 60-mile-an-hour wind the same day. Nothing happened. And that's, again, what I mentioned, the proof is
Right.
the best proofs in the pudding. And that's where 3 years of extensive testing has confirmed everything that we said about the power production, durability, the noise, the birds and bats. All these things we have said, we've proven now. And that's sort of where, like Damon pointed out, and Terry pointed out, a lot of people have had negative experiences with wind turbines. Say, oh, it doesn't work. And for those reasons. But that's sort of our uphill battle. We got to re-educate people, say, look, we've done this thing for big Fortune 500 companies. We've solved their problems. We've solved this thing, and that's sort of where the 3 years testing comes in.
You've convinced me.
Oh,
Yeah.
thanks, Lucy.
Yeah.
It really is beautiful. Dilip Nigam, he is CEO at ArborWind. Terry Phillips is handling the marketing and CMO for this Ann Arbor-based company. You can go online to arborwind.com.
Yes.
arborwind.com and learn more about that. This is going to be a really interesting company to track and see
Yes.
where you go in the future.
Yes.
You've addressed all these concerns that we've heard over and over again about wind, and the fact that you keep hearing, oh, Ann Arbor doesn't have wind, Michigan doesn't have that much wind, but this makes sense with the design and the way you've done it, and the kind of wind we do have here. So,
And we'd love to sell more in Michigan, because right now we're getting all calls from Canada, Caribbean, all over the world.
Nigeria.
really,
Yeah.
Wow.
East Africa, North Africa. So
Excellent.
everybody needs electricity at the end of the day, or energy, basically. And this is the cheapest form of energy and the cleanest. you can ever get.
And most reliable.
And most reliable.
You mentioned Pioneer High School, class of 77, then you went on to Michigan?
Yeah, University of Michigan, finishing 3 years engineering school.
3 years?
Yes.
Most people take 5.
I wanted to get out of there and make some money and get going. But it took us 10 years to do the turbine. That's what I said.
It all balances out.
And Terry, how about your journey?
I went to GMI, now called Kettering. Now I don't want to tell my age by saying GMI. Went on to U of M, got my MBA at the University of Michigan, worked at Ford, a program manager for the Explorer and Ranger for the world. Then went on, did mergers and acquisitions at World Headquarters, started my own company, doing consulting, working with NASA, startups, and then on to work with Dilip.
And both of you have automotive experience,
Yes.
and still are doing things for automotive industry?
Our focus right now is on the wind turbine. Some customers come back and say, no, please help us with this problem. But we're not actively seeking them, but they're still coming back to us.
It's a good example, though, of how important design is. You can have all the engineering in the
really is.
world, but you've got to have that design to be able to
Absolutely.
make it
Yeah,
all
'cause in this instance, the design and the engineering really go hand in glove.
Yeah.
Right? The one doesn't rule over the other. They totally support each other.
All right.
Yeah.
Exactly.
Really interesting. We got to have them back, all right? I want to hear more about this.
I think you guys are headed
And
to
you've got
the moon and back.
go talk to City Council. I'm going to for you. Thanks, gentlemen. Pleasure
Cool.
talking.
Thank you very much.
Thanks, Dean. Thank you.
On Damian Farrell's Damian on Design, which you hear each week here on the Lucy Ann Land Show on 1290 WLBY, and our guests are from ArborWind, Dilip Nigam and Terry Phillips. More coming up on 1290 WLBY. Great job, guys.
Hey, can
Thank
we
you
do that
so
one more time?
much.
I'm not totally happy.
No, he's cute too. An engineer with a sense of humor. How about that? That's wonderful.
Yeah, I didn't
Can
get to
I
sing.
see that? Let me see what it looks like.
Sure, it's plastic, so just see.
Right, right.
This is a 3D model done by U of M.
So, and this is how it works,
And
right?
this would be the generator right here
Yeah.
in your hand.
Okay,
So it's called a direct drive generator. In the sense it's directly connected to the turbine.
okay.
But because it's a 3D model, we couldn't really physically connect it.
Right,
But
right.
the whole generator's spinning with it, so what you're holding in your fingers, that's the generator.
Mm-hmm.
And that's connected to the turbine. There's no gearbox, no like your
Wow.
car's transmission is a gearbox.
Mhm.
Right. So it wears out, creates noise, lose energy.
Wow.
This is direct, so you don't lose any of that. So it's like 98% efficient.
When you see a horizontal turbine, you have two motors because with it has a fly in the wind. It moves this way.
Mm-hmm.
So you got a motor here and you got a generator motor here. So you have two. So then also if you have a problem with lubrication, you have to get a crane and go up to this point here.
Yeah.
You can't lever it out. This, you just climb right up the ladder and pull and work on this. So it's a lot easier to even service.
You
This
guys
is
are
going
too
to take
smart.
off. Pardon the pun, but it
Yeah.
just has to take off. I mean,
Yeah.
this nails everything that everyone's been struggling with.
But the utilities hate what we're doing because
So-
this literally is eating their lunch.
Yeah.
If we can produce for 10 cents, California's like 25 cents, Alaska's 40 cents, why would anybody want to work with the utilities?
Right.
And they're burning coal
But
and
you're going to
oil.
have to get those laws changed in order for this to happen.
Exactly, and we will. Ultimately, I mean, society will say, look, this is the cleanest form of
Yeah.
energy,
Yeah.
and you can never knock it out.
Yeah.